I guess most people will be watching this lecture recording afterwards. So we're going to work through 3 notebooks today, I think. 2 or 3 anyway. So I need to get you through the conditional expressions notebook. So you can do the last assignment problem. But first we'll talk about arithmetic because there's not much to talk about in Bash regarding arithmetic. Bash isn't really designed to do arithmetic. If you want to do any sort of numeric computing, Bash is not the platform you should be using. Right? It can do integer arithmetic on a modern desktop computer. It's probably 64 bits, but there's no guarantee of that. It really depends on your Bash installation. It has all of the usual arithmetic operators for integer operations, right? So parentheses, multiplication, division, so on and so forth. It also has the double star operator, which does integer exponentiation in Bash, should you need to do so. Again, it's probably unusual that you would actually need to do so, although I think the assignment does, the assignment does make you compute a binary value, so the exponentiation operator is somewhat useful on the assignment. But if you're using it, there's probably not really a great reason to use it in Bash. All right, so if you want to do arithmetic in Bash, you typically do it inside of double round brackets. So inside of the double round brackets, Bash will treat the expression as being an arithmetic expression. If there are variables inside the double round brackets, then Bash, you don't need to use the $ to dereference the variable. Because Bash understands that the string, in this case x, is a variable name and not a string, because you're inside of double round brackets and you're doing arithmetic. Right? So there's no confusion here on whether or not x is a variable or if x is a string. Right? X must be a variable in this context. Okay, if you run that example, I mean, no surprise, it prints 3. Right? Here, again, no surprise, the result is going to be 5, right? And the value of z will be assigned to be 5. Right? Notice again that the spacing doesn't matter in this case, like it does if you weren't inside of double round brackets. And the variable names, they don't need to be dereferenced using the $. Now the interesting thing is what happens if you use a non-numeric value inside of the double round brackets. Right? And so any non-numeric value or empty value or unset variable has the value 0 inside of the double round brackets. Right? So there's no error to indicate that you've used an unset. Whoops, what just happened? Oh, there's no error to indicate that you've used a non-numeric value or an unset value or an empty value. Right? It just gets turned to 0. Right? So here I've got the string ABC. Right? I'm going to add ABC to 5. Right? And surprisingly, you get 5. Right? So you get 5. Right? Here I've got the empty string plus 5, and you're going to get 5. Right? The unset command removes a variable from the current environment. Right? So unset x basically deletes x from the environment. Right? So x no longer exists now. Right? So if I take x now, right, which doesn't exist anymore, and divide it by 5, right, Bash creates the variable x, and then assigns it the value 0, right, and then actually it assigns it the value of the empty string, and then it divides by y, right, and you get 0. So just let me echo x here. Right. Notice that x is printed after the 0, so it's actually the empty string. Right? It's not 0. Right? Its value gets treated as 0, but it actually gets set to the empty string. And it does, in fact, exist. Right? Okay, so the double round brackets, it turns out it's actually a command in Bash, which seems unusual. But when you think about how Bash is structured, how everything is basically a command or a string, it kind of makes sense that the double round brackets are actually a command. Right? And that means it has an exit status, because every command in Bash has an exit status. So the way it works in Bash is if the expression evaluates to 0, then the exit status gets set to 1. Right? If the value inside the brackets is not 0, then the exit status gets set to 0, right? Which is funny, but that's the way it works in bash. Okay, so if expression is equal to 0, exit status is set to 1. So that's like saying the command ran into an error, right? Which is a bit odd, but that's how it works. Right? The reason it works this way is because in C, the value for false is 0. Right? So if an expression evaluates to 0, then you can imagine that that expression, if you use the expression in a condition as a condition, then that would be false. Right? It corresponds to the C false, which corresponds to the bash's exit status being non-zero. So it's the opposite, which is confusing, but that's the way it works. All right, so here's an example. So I'm going inside the double round brackets, I'm going to compute 0 plus 0, right? And then I'm going to print the exit status of that command, and you're going to see it's 1. Right? It doesn't matter what this expression is, as long as it's an arithmetic expression. If it evaluates to 0, exit status is 1. Right? So you could just do 0. I think that's a valid expression in bash. Yeah. Right. So you could just do that. Right? So 0 plus 0. Right? Anything that's non-zero has an exit status of 0. Right? So in other words, it's like a command that encountered no errors. All right, so can you use the double round brackets as a condition? The answer is yes, you can use it as a condition. Right? So I think in the previous lecture, or maybe 2 lectures ago, I showed you how you can test the number of command line arguments. Right? So the number of command line arguments, it's an integer value, so it's useful to use the double round brackets here as a condition. Right? So here, if the number of command line arguments is not 1, right, then this part here runs. Right? So the script requires 1 argument. Remember what this does? Right? Oops, sorry. Hey, okay. Remember what this does here? Right? So that redirects standard output to standard error. Right? So in other words, that redirects the output of echo to standard error instead of setting it to standard output. Right? Remember what exit does? Exit exits the script and sets the exit status of the script to that value there. So that will exit the script with an exit status of 1, right? Indicating that the script encountered an error. Right? Here's an example where you test if the number of input arguments is less than 3, right? So 0, 1, or 2. And then this script also exits with a message saying that the script requires at least 3 arguments. The following script is a bit odd. So if you want a command that, well, here, let me show you something else first. Let me just insert a cell here. Insert cell above. Okay, so in bash, there's a command called true. Echo $? Right, so there's a command called true. It does nothing except set the exit status to 0. Right? So in other words, true is, true would be, if you run the command true, that's like running a command that has no error, that doesn't run into an error. Right? And its exit status is 0. Right? So similarly, there's a command called false. Right? And not surprisingly, its exit status is not 0. Right? And so you can use the commands true and false like they were Boolean values. Right? So if you wrote if space true, right, then that runs the true command, right? And the result of the true command is the exit status 0. Right? So it turns out you can use the exit status as a condition. Right? If the exit status of a command is 0, then the condition is considered to be true. Right? If the exit status of a command is not 0, then the condition is considered to be false. So if you want to write a similar command, right? So you want to write a command that does something like return true or false, right? Then to return true, you set the exit status of the command to 0, and to return false, you set the exit status of the command to be non-zero, right? So I can write a command called isEven that returns, quote unquote, returns true, right? If the argument is even, right? And it returns quote unquote false if the argument is odd. right? So if the number of command line arguments is not 0, right, then we're going to get the first command line argument, right? I'm going to use an arithmetic expression here to evaluate is the remainder of dividing the value by 2 not equal to 1, not equal to 0, right? So in other words, is it odd, right? If it's odd, we exit with 1. So we exit, in other words, we quote unquote return false, right? Otherwise, the script just ends, right? And if the script just ends, then it sets the exit status to 0 or quote unquote returns true. Yeah?
Just replace exit 1 with false.
Sorry, can you do what?
Could we replace exit 1 with just false?
Yes, sure. Yeah, absolutely, you could, yes. Right. So, is 2 even? Yes, right? Is 3 even? No, right? If you run it with no arguments, it assumes that it's even, right? So no arguments also assumes that it's even. All right, that's basically all there is to say about arithmetic in Bash, right? You do it inside double round brackets. You don't need to put the $sign in front of your variables. The following is just a little example of writing a simple random number generator in Bash. So there's this, Bash has this variable called random, big R, it's all caps random, right? Every time you look at the value of that variable, it gets set to a random value between 0 and I think that's 2 to the 16 minus 1, right? So some random value, some random integer value, right? So every time you look at the value random, it gets set to a different random value. So you can use it as a very crude random number generator. It's not a strong random number generator, right? So you're not going to write a cryptographic algorithm using this. But if you need, for some reason, you need a random number, and you really don't normally need a random number in Bash, but if you did, there's a way to get one, right? So instead of always getting a number between 0 and 32,000 something, right? I want to be a little more flexible. So I either want to get a I either want to use the value of random directly, right? Or I want a random value between 0 and some specified value, right? Or I want a random value between two specified values, m and n, right? Why is that star there? Hang on just a second. There's a, oh, I see. Why is that star there? No, that didn't work either. Between dollar, oh, sorry, that should be a $sign. This is, I don't know if it, this is a language called Markdown. That's what these, that's what the text in the notebooks is written in. Okay, so depending on the number of input arguments, I'm going to return one of these three values, right? No command line arguments, then I'll return a value between, I'm just going to return the value of random, right? One command line argument whose value is n, I'm going to return a random number between 0 and n minus 1. Two command line arguments, I'll return it between m and n minus 1. Right? So here I'm checking if the number of command line arguments is greater than 2. I'm going to flag that as an error. Right? If there's one command line argument, right, just return the result of random, or print the result of random, sorry. One command line argument, then I want a random number between 0 and 0 and, what did I do here? Oh, $1, okay, right? Then I want a random number between 0 and the command line argument minus 1, right? So to get a random number between 0 and the command line argument minus 1, you just use the remainder operator, right? So x%y computes the remainder after dividing x by y, right? So that gives you back a random number between 0 and y minus 1. If you want a random number between m and n, here we're assuming the second argument is bigger than the first, right? Then all you do is you take n minus m, right? So the two values, you subtract them. That's the width of your range, right? Compute the remainder after dividing by that value, and then add the minimum value of the range, which we're assuming to be the first argument. Right? And so that gives you a value between $1 and $2 minus 1. Right? And if you run the script, right? So that's no command line arguments, some random number between 0 and 32,000. Right? That'll give you a random number between 0 and 9. And that'll give you a random number between 30 and 40. Right? And of course, if you run it again, you will get a different, well, you'll get another random value. Right? And so on and so on and so forth. Right? And so there's a little example of using arithmetic in a script. Right? And in the assignment, you also have to do some simple arithmetic. Right? Again, Bash isn't really designed to do arithmetic. And so it's normally, there's not really, so normally in a script you're not doing very much arithmetic calculation. All right, I'm going to jump ahead. So if you're the order of the notebooks, I have to jump ahead to the if statements. So this is actually towards the end of the Bash notebooks. Right, so I'm going to jump ahead to the conditional statements notebook. All right, so in Bash, when you write an if statement, right, it looks, the general form of the if statement looks like this. Right? So if some, now notice this is a command, right? So think of this as a condition, but remember that in Bash, commands are also conditions, right? So if some condition, semicolon then, right? ELIF, so else if, right? Some condition, semicolon then. Right? You can have an else if you need it, right? And then the if statement ends with phi, right? So fi. The semicolon here is actually the command separator, right? So a few lectures ago, I mentioned that if you have a sequence of commands, you can separate them with semicolons. So that semicolon is actually separating that command from the then. Right? So in other words, if you want to, you can put the then on the other line, like that. It doesn't matter which way you write them, just be consistent. Right? If you prefer to write it like that, that's fine. So Bash is a bit odd in that commands are used as conditions. Right? So every command has an exit status. Right? An exit status of 0 indicates success. Right? Non-zero indicates failure of some kind. So in an if statement, if you use a command as the condition, right, then the condition is considered to be true if the exit status of the command is 0. Right? So in other words, if the command encounters no errors, the condition is considered to be true. Right? This is where I tell you what true and false, the command's true and false. Okay, so here is a command. Here's a little script that tries to switch to a directory. Right? If it switches to the directory successfully, it lists the contents of the directory. Right? Otherwise, it prints out an error message and exits with an exit status of 1. Right? So notice the structure of the if statement. Right? So if, right, and then our condition, right? Our condition is just a command, so it's the command it's the command cd $1. Right? So in other words, try to switch to the directory whose name is the first command line argument. Right? If that succeeds, right, then run the ls command. Right? Otherwise, print your error message and exit. Okay, so if I run that script on the current directory, that has to work. Right? So all it does is try to switch to the current directory, which always works. Right? So it lists the contents of that directory. Right? If you try to switch to a different directory, so here I'm trying to switch to root, bad dir name, right, which doesn't exist on this computer. Right? You end up with, notice you end up with 2 error messages here. Right? So the first error message comes from cd. Right? So back here. Right? So if you can't switch to the directory specified by $1, right, then cd also outputs an error message. Right? So cd says, bad dir name, no such file or directory. Right? And then you get the R error message, which says error changing to directory /bad dir name. So here you end up with 2. If you want to, you can redirect the standard error message from here, right? So you are allowed to put a redirection there if you wanted to, right? And so you can suppress the error message from CD. Do I do it here? Oh, I do. I actually do it a different way here. So here I redirect the error message, right? So remember, all error messages go to, typically error messages go to standard error, which is file descriptor number 2. Right? So I redirect standard error to this file called root dev null. Right? So I think on every Unix system, there is a file called /root/dev/null. Right? And so that file is basically, you can think of it as being in a bottomless pit. Right? Anything that gets redirected to dev null just disappears. Right? It goes nowhere. And so that just discards standard error, right? Tosses it away, right? And now if you run that command, you only get our error message, right? So the error message from CD just gets tossed away. Okay, so you can use the result of a command as a condition, but more commonly, you actually want to write something that corresponds to a condition in a programming language like Python or Java. And so I'm going to tell you about the double square bracket construct. But what you should know, or you should be aware of, is that there's also a single square bracket construct, right? Which is equivalent to the command called test, right? So on all Unix systems, there is a the single square bracket construct. Sorry, not on all Unix. On most shells, there's a single square bracket construct. Bash adds this double square bracket construct, and so does Z shell that's used by Mac. Right? And so the double square bracket construct is similar to the single square bracket construct, but there are fewer surprises when you use the double square bracket construct. Right? If you click on that link, so if you want to know what the differences are, you can just click on that link. I'm just going to use the double square bracket construct because there's a lot fewer traps that you run into, but when you use it. But you have to remember it's only available on certain shells, right? So if you're in a job where you're writing a shell script, and that shell script needs to run in many different shells, you have to go and find out. You have to go and read up on the single square bracket construct. Okay, so inside the double square bracket construct, you're allowed to put in some expression. Right? If the expression evaluates to 0, then that's considered, if the expression evaluates to true, then the result of the double square bracket construct is 0. Right? So in other words, it's a command. Right? If the expression evaluates to true, then the result of the command is the exit status 0. Right? If the expression is false, then the result of the double square bracket command is 1 or not 0. Yeah, it's 1. Right. Now, the way that's written is important. There's a space here. Right? So there's a space after the second square bracket, and there's a space before the first closing square bracket. Those spaces have to be there in order for Bash to parse that expression correctly. If the space is missing, then Bash gets confused and it doesn't know that it doesn't understand the expression. Right? Thus the yellow box here. Right. Okay, the reason I'm showing you the double square bracket instead of the single square brackets is because inside double square brackets, there's no word splitting or file name expansions. Right? So they get suppressed. Which is nice, right? So when you use a variable, you don't have to worry that the variable is going to be the value of the variable. When you use a variable substitution, you don't have to worry that the variable substitution is going to end up with being word split or expanded to a bunch of file names. Right? And what does that mean? It means you probably don't have to double quote any variable accesses inside of a double square brackets. Right? It's not true with the single square brackets. So in single square brackets, you're always worried about, do I have to quote this variable or not? Okay, so what can you do with these double square brackets? So there's a bunch of expressions that you can use, and they're grouped broadly into these categories. Right? So there's one miscellaneous expression. Right? There's a bunch of expressions that work with files. There's a bunch of expressions that work with strings. There's a bunch that work with integers, and then there are some that are called regular expressions, which we'll talk about in a different lecture. You can find a complete list of expressions, so if you need to look up the actual expressions and their full documentation, just follow that link. These are the most common ones, are shown in the table here. Okay, so miscellaneous expressions. So minus v followed by the name of a variable, right? Evaluates to true, right? If that variable has been assigned a value, right? So let's jump ahead to an example. Right. Okay, so here I'm going to unset the variable x, right? So I'm going to remove x if it's in the current environment already, right? So there is no variable x. So here, I'm using minus v, right? So double square brackets, space, right? Minus v, right? Space, name of the variable. Now here, notice here, if you're using minus v, it's not $x, right? It's just the variable name. Right? So you don't dereference x, right? So x doesn't exist in this in the shell right now. So if I run this, I should get x is not assigned. Right? Because x doesn't have a value. Right? If x has a value, right? So in other words, if x is set in the environment, right? It could be the empty string. Then, when you use this test expression, right? X will be assigned, right? So you'll end up minus vx will evaluate to true, and so this will say x is assigned a value. Right, so if you need to know does the variable have a value, you can use minus v inside of a test expression. All right, let's go back up to the table quick. All right, now we've got a bunch of file expressions. So these are expressions that work on file names. Right, so minus d tells you if the file is a directory. Right, minus e tells you, does the file exist? Now the file could be anything, right? It could be a regular file, it could be a directory, it could be one of the block special files, or so on and so forth. Right? So minus e simply tells you, is there some file? Does some file with this name exist? Right? If you want to know if it's a directory, use minus d. If you want to know, is it a regular file, use minus f. Right? Okay, so once you've established what type of file you have, right, you may want to know, is it readable, writable, and or executable? Right? So minus r, does the user have read permission? Right? Minus w, do they have write permission? Minus x, do they have execute permission on that file? Right? These also tell you if they exist. Right? So minus r, w, and x also tell you if the file exists. S is the file size greater than 0? Right, so does the file exist and is the file size greater than 0? Right, you can compare two files by their modification time. Right, so is file 1 newer than? Right, so minus nt is newer than. Right, is file 1 newer than file 2? Is file 1 older than file 2? Right. So let's look at how you use these ones. Now these expressions exist because, I mean, files are fundamental to the Unix operating system. Right? And so a lot of the scripts that you write involve dealing with files. So it's not unusual that these expressions are part of the double square bracket notation. Right? Notice that the commands are spilling over because I have the zoom set very high. So this command is actually all in one line. Okay, so here we've got a script. It takes in one command line argument, which is the name of a file. Right? And now we're just going to ask, does that file exist? Right, sorry, minus e. Right? Does the file exist? Right? If the file exists, right, we're going to ask, is the file a regular file? Right? Is it a directory? Is it readable? Is it writable? Is it executable? right? If it doesn't exist, we're going to print out that the file doesn't exist and then exit with the status of 1. This should be redirected to standard error, but it looks like I forgot to do that. Right? So in other words, all this script is going to do is it's going to take in a command line argument. It's going to test, does the file exist? And if it exists, it'll print out some information about the file. Right? So scripts, in this directory, scripts is a directory. Right? So if we run that, it says scripts is a directory. It's readable, writable, and executable to, I think, me. I assume it's me, the user, when I'm running it inside a Jupyter notebook. Right? So this is testing, sorry, let me take the zoom down a second for a little bit. Oh, sorry, not that. Control, what did I just do? No, I cannot. How do I unzoom this notebook? Control minus? There we go. Where'd it go? Here. Okay, so does the notebook conditional statements exist? Well, I'm in that notebook, so it had better exist. Right? So it's a regular file, it's readable and writable, not executable. Right? If you run it with a file that doesn't exist, it tells you that file doesn't exist. Right? So that's how you test for existence of and the properties, I guess the permissions for a file. Right? So existence of, the type of file, and the permissions for a particular file. Right? And that should get you through, I think, assignment, the last question on the assignment. Shift, boop, boop. Okay. String expressions. So strings are also fundamental to the Bash scripting language. So there's a whole bunch of different types of expressions that you can use to test strings. Strings. All right. So if you just use the name of a string, or if you just use a string, sorry, then that test is the length of the string 0, right? Or not 0, I guess. Right. So if some string returns true if the string length is greater than 0, right? Which is the same as minus n string, right? So minus n can also be used. Minus z is the string length 0, right? So is it empty? If you want to test if two strings are equal, you can do it in 3 different ways, although you should really use only the first 2, right? So you can use the single equal sign or the double equal sign. Those both do the same thing inside of the double square brackets, right? So is string 1 equal to string 2, right? Equals tilde does what's called a regular expression match to string 2, right? So does string 1 match the regular expression string 2? So I'm going to tell you about regular expressions in the next lecture. Not equals is, not surprisingly, exclamation mark equals. You can compare strings by dictionary order using greater than and less than, right? So string 1 greater than string 2 is true if string 1 comes after string 2, right? And string 1 less than string 2 is true if string 1 comes before string 2 in the dictionary. Where are we? String expressions. Okay. So if you want to test is a string empty or not, right, then just use the value of the string, right? So here I can just write $s in this case. Right. So if $s, so if s is, if the value of s is not empty, that'll be true, right? So it turns out it's false in this case, right, because I have the empty string. So as soon as you put something inside the string s, right, it now says not empty. Right? So the name of the string is identical to minus n. Right? So in other words, these two things are exactly the same. Right? So this will also print not empty. If you want to test for an empty string, you can either negate the result of this test, right? Or you can use not the z, hyphen z. Right? So this tests if the string is empty. Right? So this should print empty, right? And if it's not empty, it should print not empty. Okay, now if you want to compare 2 strings, but you have to remember not 2 integers, right? So this is the weird part about this construct. If you want to test two integers, the syntax is completely different, right? So if you're testing integers, use double round bracket. It's a lot easier, right? If you're testing anything else, then it's probably the double square brackets, right? So if you want to test strings for their dictionary order, you can use equals, 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 less than, or greater than, right? So this is like Java's compare to method for strings, right? So compare to returns a negative value if string 1 is less than string 2, right? It returns 0 if they're equal. It returns a positive value if string 1 is greater than string 2, right? So string 1 and string 2, right, from the command line arguments, right? If they're equal, then we're going to print 0, right? If string 1 is less than string 2, we're going to print -1, right? Otherwise, we'll print 1. So is cat equal to cat, right? The answer is yes, right? Does antelope come before zebra? The answer is yes, so -1, right? Or compare tiger to poodle. Tiger comes after poodle, so the answer should be 1. The answer should be 1. Tiger comes after poodle. That's interesting. What did I do there? I must have edited that script. Sorry, so I guess if we actually look at the text for that script, there must be some extra text in there. Okay, so this always catches some student unaware, right? When you use equals, equals, or less than or greater than, it's always string comparisons, not numeric comparisons. The problem is in Bash, numbers are essentially strings, right? So this script works if you pass in two strings. It just gives you the wrong result, right? So if you try to compare 100 to 2 using less than, greater than, and equal to inside of double square brackets, right, you end up with the result that 100 is less than 2, right? Because 100 comes before 2 in the dictionary, right? Because the 1 is less, because the 1 compares as less than 2, right? So 100 is less than 2 as well in dictionary order, right? So you have to be very careful about that, right? If you're going to compare numeric values, just use the double round brackets and you'll never run into this problem. So for now, we can ignore the pattern matching part because you need to know about regular expressions. Oh, wait. Oh, I guess we can do this now. Okay, so if you use equals, equals, or not equals, then you can also use pattern matching here as well. So the string on the right is considered to be a pattern if it's not quoted, right? If you quote it, it's no longer a pattern, right? And so what does that mean? It means you can use the characters star, question mark, and the square brackets to create a character class, right? So remember that star. Now, also remember here that it's only the right-hand side that's considered a pattern, right? The left-hand side is not considered a pattern. Right? So here, right-hand side is a string and it's not quoted, right? So Bash will treat this as though it were a pattern, right? Now remember, star matches any string, right? So this will return true if that string is any string that starts with an A, right? So it starts with an A, right? And this can be any string that starts with an A, right? So it doesn't have to be avocado, it could be ABC, right? Which also starts with an A. If it doesn't start with an A, then obviously it says it doesn't start with an A, right? So as long as that thing on the right is not quoted, it gets treated as a pattern. Oh, wait, that's wrong. There's a lot of typo in these notebooks. That's supposed to be a question mark. Okay, so the question mark matches any single character, right? So if the string starts with an A, ends with an A, and has something in between, right, then that will match, right? So Ada will say, so that'll print matches, right? ABBA will not match because there's two B's, right, whereas there should only be a single character. Right? And finally, the square brackets, remember these define a character class, right? So it'll match any single character inside the square brackets. So if you wanted a postal code, right? So is that string a Canadian postal code, right? Then you would want to match a letter followed by a number, followed by a letter, followed by a number, followed by a letter, followed by a number. Right? And so that prints that might be a postal code. Right? If you insert, or if I change that 7 to a letter, what's going on? Control K, right? That says it's not a postal code. Right? So you can also do pattern matching as well. And then finally, there's a more powerful form of power matching called regular expressions, but we'll get to that in the next lecture. Okay, and finally, the integer expressions. So I'm going to tell you these just for completeness, sorry. But again, if you're comparing integer values, you really should consider using double round brackets instead. Okay, so you can't use less than, greater than, or equal to for the integer values. So what do you do instead? So instead, you have to use these funny minus EQ for equals, minus NE for not equals, minus LE for less than or equal to, less than, greater than or equal to, and greater than. Right? Notice that this is a lot harder to remember than just using the symbols less than, greater than, and less than or equal to, and so on and so forth. Right? But if you want to use them inside double square brackets, you can. Right? So where are they? Integer expressions. Right? Okay, so this is Java-like comparison for two integer values. Right? So is integer 1 less than, greater than, or equal to integer 2? Right? And I've written it in a funny way just to show you how to use the operators. Right? I've also used the $sign even though you don't have to. I'm sorry, inside the square brackets you have to use the $sign. Never mind, sorry. So notice that inside double round brackets you don't need the $sign. Inside square brackets you have to use the $sign. So that makes these even more awkward to use when you're doing arithmetic comparisons. Right? So I1 and I2 are two integer values. If they're not integer values, they get set to 0. They get treated as being 0. Do I show you that anymore? I do, okay. Which is, again, weird, right? So, but that's the way it works in Bash. So if I1 is not equal to I2, right, and I1 is less than I2, then we'll print -1, right? Otherwise, right, if I1 is not equal to I2, then we're going to print 1, right? Else, we'll print 0 because they're equal. Of course, you could write this in a much more compact way, right? So is 5 equal? How do 5 and 5 compare? They compare as being equal. How does -3 compare to 12? It compares as less than. Right? Sorry. How does 22 compare to 21? It compares as greater than. Right? Non-numeric values, they get treated as 0. So how does hello get compared to goodbye? Numerically, they're equal. Right? How does ABC compare to 3? It's less than. How does 12 compare to XYZ? It's greater than. Right? Okay, if that wasn't confusing enough, it gets worse. Right? So there is a way to write down numbers in a different base in Bash. Right? So you can write down base 2 numbers. So for example, the binary number 101, you can write in base 2 as 2 pound 101. Right? There's also a way to write octal and hexadecimal, I believe, I think. So it turns out not everything that doesn't immediately look like a number automatically will get converted to 0. Right? So here, Bash will treat 2 pound 101 as being the number 5. Right? So instead of being 0. Right? So this one does in fact, so 5 is in fact bigger than 1. And it gets worse because of the rules that Bash uses to parse an integer expression. You can actually end up with an error in this case. Right? So notice that when you just use a string, right, you never get an error. However, if you do the following, right, so 2 starts with a number, and then there's some text after it, right? So in this case, Bash complains, right? And you get some sort of funny error. So the error here is caused because when it looks at the 2 ABC, it starts to think that the 2 is a number, and then it runs into the ABC, and then it gets confused, right? And so this one, in fact, leads to an error. All right, is there anything else? That's 12:15. So I think the rest of this notebook is deals with, so this one is going to be the regular expression part. So I'm going to talk about that in the next class because it's going to take a full lecture to talk about regular expressions. So we'll stop there for today, and I will see you on Monday, I guess. So later this afternoon, I'm going to post an announcement on OnQ to tell you about the quiz, and I will post last term's quiz 1 along with the answers for you as well. Right? So you can have an example of quiz 1 for next Wednesday. And otherwise, I guess have a good weekend. Try to get home safely.